Hi. So this is the first lecture for the course of mathematics for MA Economics entrances. Okay. So course का जो outline है that I have already sent you. So it includes real analysis. Okay. And रियल एनालिसिस में ही और सारे जो चैप्टर्स हैं कैलकुलस के वो इंक्लूडेड हैं. ओके, विल टॉक अबाउट फंक्शंस, विल टॉक अबाउट मैट्रिक स्पेसेस, सीक्वेंसेस, सीरीज, लिमिट्स, कॉन्टिन्यूटी, डिफरेंशिएशन, कॉन्केविटी, कॉन्वेक्सिटी. ओके, and then we'll move on to linear algebra, in which we'll talk about null space, column space, rank, projection, etc. And finally we'll move on to optimization. Okay, so let's get started. So today we'll talk about functions. And although we are talking about functions, we are studying this concept from class 11th, but we'll have to start from that because in ever the structure would be that we'll be starting with from very basics. Okay, and then we'll move on to advanced level within the same class. Okay, so in this class, after covering some of the concepts, we'll move on to some past year questions. Okay, we'll discuss some of them. So one question is from ISI 2007. Then we'll move on to another question, which is again from ISI but 2008. Okay. Then this question is from DSC and it is from 2019 as well as from 2020. This is a repeated question. लगातार दो बार आया ये. Okay. And this is from IIT JAM. (2022) and we'll do one question from DSC 2006. Okay, so that this will be the structure for every class. We'll start with some of the concepts and then we'll do some past year questions related to that concept. Okay, so let's begin. So before moving on to functions, we'll talk about relations. So there can be a few symbols, a few technicalities which some of you might not be comfortable with. We'll talk about that and then we'll soon develop over it and we'll move to advanced level so that everyone can benefit from this class. So what's a relation? A relation between set A and set B, between set A and set B. Okay, it is basically a subset. It is a subset of A cross B. Okay, we call it A cross B, or we can say call it Cartesian product. Cartesian product of A and B. All right. So let's take an example. So if we have set A which contains suppose 1 and 2, and we have set B in which the elements are 2, 3, and 7. All right. Then what's A cross B? Well, A cross B contains all the possible ordered pairs. All right. So all the possible ordered pairs between A and B. So A has elements 1 and 2 and B has elements 2, 3, and 7. So all the possible ordered pairs such that the first element should come from A and second element should come from B. All right. So all those possible ordered pairs are 1, 2. So I have taken 1 from set A and 2 from set B. Then we can take 1 from set A and 3 from set B. Then we can take 1 from set A and 7 from set B. All right. So and so on. Then we can do the same thing for 2. Okay, starting from 2. So 2, 2, 2, 3, 2, 7. So this is the Cartesian product of A and B. All right. So when we talk about Cartesian product in mathematical terms, it is equal to all the ordered pairs xy. Okay, this is an ordered pair such that the first element of this ordered pair, this first term, that comes from set A and y comes from B. Okay, so it basically means, so we have to understand these mathematical terminologies, these mathematical definitions, because in your exam you'll be given a lot of things in this manner only. So you should understand that what does these terms actually mean. All right. So these are all ordered pairs, all ordered pairs xy. Now this is for such that all ordered pairs xy such that x belongs, this symbol is for belongs to, okay, this x belongs to set A and y belongs to set B. Okay, so that's the way you read it. All right, now we can create relations. So as I said that relation is basically a subset, relation is basically a subset of Cartesian product of A and B. So let's also talk about what's a subset. What is a subset? So if we have two sets, let's say A and B, let A and B be two sets, and if every element of A, if every element of A is in set B, then A is a subset of B. Okay, or we can say that A is contained in B. For example, so if set A has elements 1 and 2, set B has elements 1, 2, and 3. So we can clearly see that all the elements that are in A are also in B. Okay, so that means A is a subset of B, or you can say that B is a superset of A. Okay, you can just reverse this symbol. You can flip it. So we call this A is a subset. A is a subset of B, and you can call it B is a superset. It contains all the elements that A has and some extra elements as well. So it is a superset of A. Okay. If two sets are equal, let's say two sets are equivalent, then let's say the sets are C and D, then we say that C is an improper subset of D. So there is a set C which has elements A, B, and C, and there is another set D which again has A, B, and C. So we won't say that C is a subset of D. Actually, it's a improper subset of D because they both are equal. So you can say that C is an improper subset of D, and as well as D is a improper subset of C because they both are equal. So we use this equal sign here as well along with the subset sign. So this is improper subset. This is proper subset because here B has all the elements that A has as well as an extra element. Okay, so A is a proper subset of B. But here C and D are equal, so we use this symbol, and this is for improper subset. Okay. So now let's talk about relation. Relation is a subset of this Cartesian product. This Cartesian product. Okay. So we can create different relations here. So one of the relations can be that, let me call it R1. So R1 is the relation number 1. So it might contain this element of Cartesian product as well as 1, 7. So this is one of the relations. Okay. Let R2 be 2, 3, 1, 7, and 2, 7. These are the elements in relation to 2. Okay. So this is a subset. Okay. This is a subset of A cross B. So they both are relations. We can also form relations in the form of a set. Okay. We can define that relationship. Okay. So I can say that uh, this relation should have ordered pairs such that x is more than or equal to y. Okay, we can create such relation. So R3 will contain. So here, if you compare between 1 and 2, 1 is actually less than 2. So x is less than y here. So this is not satisfied in the relation. Here also 1 is less than 7, but here 2 is equal to 2. So this can be included in this relation, right? 2, 3, 3 is bigger. 2, 7, 7 is bigger. Okay. So in this relation, we have just one element, which is 2, 2, right? We can also create a relation like all such ordered pairs such that x plus y is greater than or equal to 3. Okay, we can create such relation. So here sum is 3, so satisfied. So R4 will contain this element, which is 1, 2. 1 plus 3 is 4, so this is also contained here. 1, 7, sum is 8, 2, 2, sum is 4, 2, 3, sum is 5, 2, 7, sum is 9. So all of these elements are actually part of this relation, because this uh, this relationship, this definition that I have created is satisfied. Okay. So 1, 7, 2, 2, 2, 3, and 2, 7, all of them are satisfied. All of them satisfy this condition. Okay. So we are done with relations. Now we can talk about functions. Okay, let's talk about functions now. तो जल्दी से ये बेसिक्स एक बार बिल्डअप कर लेते हैं, then we can increase the level, and if you're even if you're aware about these concepts, then also you'll find something new in this class. So let's talk about functions. So function is also a relation. Function is a relation with, so in functions we have a domain. Okay, I haven't defined domain yet. So with domain A, basically we'll call it inputs, or when you have an ordered pair xy, this part of this ordered pair is the domain, or we can call it input, and this part of this ordered pair is the output. Okay, so we use inputs to get output from this function. So function is a relation with domain A and codomain B. So codomain is set of outputs. Okay, such that for each element in A, there is exactly one element in B. All right, and so you can call it exactly one, or you can call it unique. So there is a unique element in B for A, or exactly one element for that input. Okay, so focus on the word each element, or just each, and exactly one. So all of the elements in the domain set, of the input set, okay, has to be mapped or associated to exactly one, or to a unique element in B. So these two are the keywords. These two are the conditions that must be satisfied when you talk about functions. If you want to say that a particular relation is a function, then these two conditions must be satisfied. Okay. Let's see an example. So we have a set of inputs. I'm talking about a function where domain is set A and codomain is set B. Okay, let us check. Let's take an example. Example number 1. So this is set A, which is a set of inputs, and this is set B, which is a set of all possible outputs. Here we have 1, 2, 3, and 4, and in set B we have 5, 6, 7, and 8. All right. So if 1 is mapped to 6, 2 is mapped to 5, 3 is let's say mapped to 6, and 4 is mapped to 7. So the question is it a function? So we'll have to check two things. First is that each element of the domain set has to be associated to exactly one element in B. So first condition is that each element has to be associated of set A. Okay, so 1 is connected, so that's fine. 2 is connected, fine. 3 is connected, fine. 4 is connected. Okay, so there is a arrow coming out of each one of them. Okay, so each condition is satisfied. Then the second condition is that they are mapped to exactly one element. So one is there is exactly one arrow coming out of one, so it is mapped to exactly one element, which is 6. 2 is mapped to a unique element 5. 3 is mapped to exactly one element 6. 4 is mapped to exactly one element, which is 7. Okay, so both the conditions are satisfied, so we are done. So that means it is a function. So yes, it is a function, right? So you can also write it as in this function. In this function f, we have the input is 1, which is giving output 6. This function is giving you output 6 when you use the input 1. When you use the input 2, you are getting 5 as output. When you use the input 3, you are getting 6 as output. And when you are using 4, you are again getting 6 as the output. Okay. So you can notice that 6 is associated to 1 as well as 3. So that's not an issue in terms of in terms of function, because the conditions which are required for function, that is satisfied. Okay, so this is not a problem. For 1, we have a unique element in B. Okay, so for this particular element, we have exactly one association, which is 6. And for 3 also, there is exactly one association. So there is no issue from this side. Okay, we have to check that each of these elements are associated with exactly one element in set B. So that is satisfied. So now the thing is, what is domain? So clearly, domain contains the uh, elements 1, 2, 3, and 4, right? Codomain is clear. Codomain is set B, which contains 5, 6, 7, and 8. But notice that 8 is actually not associated to any of the elements in the domain. Okay, so the thing is, there is something called range, or we can also call it image. So image is the set of actual outputs. Codomain is the set of all possible outputs. So all these elements could be connected to any of the elements in set B. Okay, but only 5, 6, and 7 are the only ones to which these elements are mapped to. 8 is left. Okay, so that makes 8 and all other elements part of codomain, but 5, 6, 7 are the actual output, so that they are part of range. All right, so range or image contains 5, 6, and 7. 8 is not part of range. It is part of codomain, but it is not a part of range. Okay, because range contains these range contains only the actual outputs. Okay, though to which the elements in the domain are actually connected. All right, so from this we can uh, decipher, we can conclude that range is actually a subset of codomain. Okay, and at times it can be equal to, right? Because let's say here we have 1, 2, 3, here we have 4, 5, 6. So 1 is associated or mapped to 4, 2 is mapped to 5, 3 is mapped to 6. So this time codomain is 4, 5, 6, and range is also 4, 5, 6. So here range is exactly equal to codomain. Okay, so range is a subset of codomain. It can, the number of elements in range can be less or equal to the codomain. Okay, so let's take another example. So let's say domain contains 1, 2, 3, and 4, and codomain contains 8, 9, 10, and 11. And 1 is mapped to 8, 2 is mapped to 9, 4 is mapped to 9. So is it a function? The answer is no, it is not a function, because the definition of function says that each of the element in set A should be mapped to exactly one element in set B. But here 3 is not mapped to any of the elements in set B. So that makes it not a function. So it is not a function. Okay, because 3 is not mapped to any element in B. To any element in B. Okay. So basically, what is domain? Domain is the set of all possible inputs. All possible inputs. What is codomain? Codomain is the set of all possible outputs. And finally, what is range or image? Well, it is a set of all actual outputs. Okay. So although this is not a function, but if I want to look at the range here, range is 8 and 9. Okay. Range contains, the set of range contains 8 and 9. So image is a set of all actual outputs. Okay. Is it clear till now? All right. All right. Moving on. There's a type of functions called injective functions. Okay, injective functions, which are also called one-one or one-to-one functions. One-to-one or only one-one functions. Okay. Towards injective or one-one function. So obviously an injective function is a function. So an injective function associates at most one element of the domain with each element of the codomain. Okay, or you can say that for each element in the codomain, there is at most one element in the domain set. Okay, so to simplify it, we can say that for each element in codomain, there is at most one element. There is at most one element in domain. And by at most one, we mean at most one contains here 0 or 1. Okay. So each element in the codomain has either no association in domain, or it is just connected to exactly one element in the domain set. Okay. So let's take an example. So there is a set A which contains, let's say, 1, 2, 3, and 4, and set B which contains 5, 6, 7, and 8. All right. So 1 is connected to 5, 2 is mapped to 7, 3 is mapped to 6, and 4 is mapped to 8. Is it a 1-1 function? Is it a 1-to-1 function? Well, the answer is yes, because so the first thing that you need to check is whether it is a function or not. So we can clearly see that each element in set A is mapped to exactly one element in set B. So it is a function. Now, is it injective function? Is it 1-1 function? So for each element in set B, there should be at most one. So there should be 0 or 1 element in A. So 5 was associated to 1, 6 to 3, 8 to 4, 7 to 2. So all of them have exactly one association. So it is a 1-1 function. Now, if I take set A to be in this set, we have 1, 2, 3, and in set B, we have 4, 5, 6, and 7. So let's say 1 is mapped to 4, 2 is mapped to 5, and 3 is also mapped to 5. So is it an injective function? So it is a function. We can see that each element in set A, each element in set A is mapped to exactly one element in set B. So that it is a function. Is it a 1-1 function? Well, so for that we have to check whether each element in set B is associated to one or less. So 1 or 0 elements in domain. So 1 has one association, but 3 has two associations. So that makes it not an injective function, because it can have either 0 or 1 association. But here 3 is connected to 2 as well as 3. So it has two associations. So that makes it not 1-1. Okay. And for 6, it is satisfied because it is not uh, associated to any element in domain. So which is fine because it can have 0 associations as well. 7 is not connected to any element in domain. So again satisfied because 0 is part of the definition. So it is not 1-1. So when a function which is not 1-1, it is a many-one function. It is a many-to-one function. So why is it many-to-one function? So you can see here. So 1-1-1, what is 1-1? So each element in domain is associated to one element in B. Okay, 1-1, 1-1 relation, 1-1 relation, 3 to 6, 4 to 8. Okay, so it is a 1-1 relation. What is many-to-one? So you can see here that two elements 2 and 3 are associated to same element. So 2 are associated to one element in B. So that makes it many. This many contains 2 and 3 to 1. Okay, so many to one relationship. So it is a many to one relation. All right. Now, let's take one more example to make it more clear. If the day contains 1 to 3 and it contains 3, 4, 5, 6, 1 is mapped to 3, 2 is mapped to 4, 3 is mapped to 5. Is it 1-to-1? The first thing to question is whether it is a function, because injective function is a function, so it has to be a function first. Is it a function? Yes, because each element in A is mapped to exactly one element in B. And is it injective? Well, for each element in B, it should have 0 or 1 association. So 3 has one association, which is that it is connected to 1. 4 has one association, it is connected to 2. 5 has one association, it is connected to 3. 6 has 0 association because it is not connected to any element in domain. Okay, so all of it is a part of the definition because 0 and 1 are both allowed as number of associations. So it is a 1-1 relationship. Okay, so it is 1-1. So basically, when we are talking about 1-1 function, so if any element is in B has no association in set A, then it is not a problem. Okay, but we should just not have more than one association. All right, and it should be a function. Right, so this one is a 1-1 function. All right. So let's say we have a function fx equal to x square. Okay. So we haven't studied curve sketching till now. Okay. This is the first class. But x square looks like this. So you must have studied this in your class 11th or 12th. So this is the curve for y equal to x square, right? But if I take, let's say I take the function fx equal to root x, okay? So root x looks like this. Root x looks like this, okay? This is y equal to root x. So clearly it is a function. If I take, if I do a vertical line test, so I can see that for this x, there is exactly one association. For this x, there is exactly one association, okay? So it is a function. If I draw any vertical line on its domain, and we know that domain should be x more than or equal to 0 because it is a under root function. It is not defined for negative numbers, so it is defined for all the real numbers which are positive, okay, more than or equal to 0, which are non-negative, okay, technically more than or equal to 0, which is non-negative. So it is a function. Now let's check whether it is a 1 1 function or not. So for that, we'll be doing a horizontal line test. So for this particular y, if I draw this horizontal line, we can see that there is exactly one association. For this, one association. For this particular y, there is exactly one association. Okay, so it is part of the definition, so it is satisfied. It is. And if I look for, let's say y4, which is below 0, okay, for this negative y, if I try to see an association, turns out there is no association. But again, it is part of the definition that for each y there should be 0 or 1 as number of associations can be 0 or 1. Okay, so here we have 0 associations. So again, satisfied. So that makes square root x 1 1 function. Okay. ये clear है? You could do the same thing here as well. You can test for y3 as well. So when you test for y3, turns out there is no association. Okay. So since there is no association here, so both number of associations can be 1 or 0 in case of 1 1 function, so it is satisfied here. Okay. So another way to check for 1 1 function is that, let's say you don't know, the function is quite complex and you don't know that you don't know that you don't know the graph of that function. Okay, so what you can do is you can find out the derivative of that function. So if f dash x is strictly positive or f dash x is strictly negative, that is, if the function is strictly increasing or the function is strictly decreasing, then you can directly say that the function is injective. Okay, so let's see how. let's take an example. If fx is equal to x cube plus 3x, you can find out f dash x, which turns out to be 3x square plus 3, which is obviously strictly positive. Okay, so let's see how does this function look. X cube plus 3x. Okay, one second. So the function is x cube plus 3x. So it's almost like x cube only. Okay, so let's draw this. It looks like this. Okay, so it is a strictly increasing function. Now the thing is, why is it injective? So obviously, if there is a strictly increasing or strictly decreasing function, then in that case, if you take the horizontal line test, then obviously it will intersect the graph at exactly one point, right? Because since it is strictly increasing, it cannot change directions in between. So if it is strictly increasing, it cannot be like this. Okay, it cannot decrease in between. And similarly, if it is strictly decreasing, it cannot suddenly increase in between. It cannot change directions. Okay, since it cannot change directions, we'll have exactly one association for each y, right? Because if it suddenly changes direction, then here we can have two associations. Here we can have two associations. Okay, but here you cannot have two associations. It will have exactly one association because it is strictly increasing and it cannot change direction. Okay, so that's why if a function is strictly increasing or strictly decreasing, it has to be injective. All right. Similarly, if we have function fx equal to e to the power x, okay, where this is an exponential function where the value of e is approximately equal to 2.73. So let's see the graph of this function. Let's see if it can. Okay, so its approximate value is 2.72. So e to the power x, look at this. So it will remain above the x-axis. See, it will always remain above the x-axis, okay? And it is strictly increasing, all right? So we have this function, e to the power x, whose graph looks like this, e to the power x. So it's something like, here we have 0, so you should get what? 2 approximately 2.72 to the power 0, which is equal to 1. So this point is 1. When we have 1 here, it is e to the power 1, which should be 1, right? And e to the power 1 will be exactly equal to 1. So on 1 will have e here and so on. So basically this function is strictly increasing, right? So even if function is e to the power x, I take the derivative of it. It is again equal to e to the power x. And the thing is 2.72 approximately. If I take its power 0, I'll get 1. If I take its power 2, it will be a positive number squared. If I take its power to be, let's say, minus 1, I'll get 1 upon 2.72, which is again positive. If I take its power to be 2.72 to the power, let's say, minus 10, I'll simply get, it will be equal to 1 upon 2.72 to the power 10. So basically, it will become smaller and smaller, but it will always be positive. So whether its power is 0 or its power is 2 or its power is -1 or -10, everywhere it has to be positive. So that's why e to the power x is always above the x-axis. It is always above 0. Okay, so e to the power x is always positive. F dash x is same as fx, and it is always positive. We just saw that, so that means it is a strictly increasing function. So if I take a vertical line test, sorry, horizontal line test, then I'll get exactly one association for each x. For each y, there will be exactly one point in the codomain, one or either zero. If I move here, if I take a test here, then I'll get zero associations, right? So here we have zero associations because there is no graph here. So for these y, so any y below 0, for any y below 0, for each y you'll get zero associations. So still the definition of one function is satisfied. So e to the power x, even by horizontal line test or by derivative test, it is a one function. Okay. Moving on, let's talk about cardinality. Cardinality of a set. Basically, the number of elements in a set. Number of elements in a set is called the cardinality of that set. So if there is a set A which contains A, B, C, and D, okay? So cardinality of A, this is the symbol for cardinality, or number of elements in set A will be equal to 4. Okay, this is cardinality of A. Okay, and suppose there is a set B which contains 0, 2, 4, 8, 12. Okay, so there are 5 elements in this set. So cardinality of B, or number of elements in set B, is exactly equal to 5. Okay, so this is the cardinality of a set. Now the question is, that suppose there is a function g whose domain is A and codomain is B. All right, is an injective function. We know that. Suppose g is a injective function. Now, what is the relationship between cardinality of the domain set and cardinality of the codomain set? That's the question. Okay. So whether number of elements in set A is less than the number of elements at B, or number of elements in set A should be more than the number of elements in set B for this function to be injective, or number of elements in set A should be equal to number of elements at B, or it should be less than equal to, more than equal to. What should be? Okay, what should be the case? What should be the exact relationship between cardinality of A and cardinality of B? क्या आएगा बताओ? ठीक है, ट्राई करते हैं. So there is set A which has, let's say, 2, 3, 4 elements, and there is a set B which has, let's say, 5 elements. Okay, now let's say these two are mapped, these two are mapped, these two are mapped, and these two are mapped, and we are left with this one. Now the thing is it injective function? Is it injective? Yes. So because it is a function, we can see that each element of A is associated with exactly one element in B. That is fine. It is a function. Is it injective? Well, for each element in B, there should be 0 or 1 elements in set A. So all of these have 1 elements and this one has 0 elements in set A. Okay, so definition of injection is satisfied. So it is 1 function. Okay, so more elements in set B can be there. Okay, what if there are equal number of elements? So 1 2 3 4, 1 2 3 4, I can have a relationship like this. So obviously this is also 1 function. All the definitions are satisfied. Okay, this is quite clear. This is A, this is B. So equal elements is also fine. Okay, if cardinality of A, if number of elements of set A is equal to number of elements in set B, then also we can have a 1 relationship. Here number of elements in set A is less than number of elements in set B. So here also definition for 1 can be satisfied. But let's say what I do. What if I take less number of elements in set B than in set A? Then what will happen? I can associate these two, and these two. Now the thing is, this is no longer a function. I have to associate this to some point, right? If I try to associate it to this, okay, then there is a y in set B such that it has two associations. Okay, it has two associations, so that does not satisfy the definition of injective function, so it is not allowed. And if I don't associate this particular x to any of the y's, then that makes then this is no longer a function, because each of the elements in set A should be mapped to exactly one element in B. So if it is not associated to any of the points, then this is no longer a function. Okay, so if there are less number of elements, so if an A is more than an B, then we cannot have, then we can't have 1 function. Okay, so that's why the relationship in case of 1 function that exists is that cardinality of A has to be less than or equal to cardinality of B. Or you can say that number of elements in set A should be less than or equal to number of elements in set B. Okay, so this should be the relationship that should hold in case of injective functions. Clear? Eh? Yes? Okay. Now let's move on to surjective functions. Surjective, or you can say onto functions. So again, obviously a onto function is a function first, right? So a function f whose domain is A and codomain is B is called surjective. It is called surjective, or it is called onto if each element of codomain, each element of codomain is associated to at least one element in domain, at least one element of the domain. So if you remember, for injective function it was at most, and for surjective function it is at least. Okay, so basically a single liner can be that for every possible output, that means for every element of codomain, so for every possible output there is at least one input. So here at most one means that it can be 1 or 2 or 3 and so on. Okay. And for at most 1, because we are talking about a number, it cannot be negative. So it can be either 0 or 1. And here it can be 1, 2, 3 or anything more than that. Okay. In Let's take an example. So in set A we have A1, A2, A3, A4, and in set B we have B1, B2 and B3. So A1 is mapped to B1, A2 is mapped to B2, A3 is mapped to B2, and A4 is mapped to B2. Okay. So is it surjective? It is function clearly because each of the elements in set A are associated to exactly one element in B. Okay, one arrow, one arrow, one arrow, one arrow. Okay. So it is a function, right? Is it injective? Well, for each element in codomain, there should be at most one element in set A. Okay. So for B1, we have one association. For B2, we have three associations. So it should have at most one association. So it is not injective. Is it surjective? For B1, we have one association. For B2, we have three associations. We can have at least one association. Okay. And for B3, there is no association. And 0 is not part of this set, right? We should have at least one association for each element in codomain. So since B3 has no association, so that makes it not surjective because because B3 has zero associations. Or you can say that for B3 we don't have any element in domain set. All right. Similarly, if we have A1, A2, A3 and A4 in set A, and we have B1, B2 and B3 in set B, A1 is associated to B1, A2 is associated to B3, A3 is uh, mapped to B3, and A4 is mapped to B2. Is it function? Tell me, is it function? Think about it. Well, each element in set A is associated to exactly one element in B, so it is a function. Exactly one association for each element of domain. Is it injective? Well, B3 has two associations. It can have at most one association, so it is not injective. Is it surjective? Well, B1 has one association, B2 has one association, and B3 has two association. And for being surjective, it should have each element in B should have at least one association, so that is satisfied. Okay, so it is surjective. All right. Let's pick a question. Question is that what domain and codomain make this function f, which is basically x square, a surjection. Question is basically that if the function is equal to x square, for what domain and codomain will it be a surjective function? That's the question. Question clear? Hai? So we know that x square, the function of x square, the graph of it looks like this. Okay, this is y equal to x square. So definition of surjectivity or surjection says that for each y there should be at least one association, at least one. So if I take any point here and if I draw a horizontal line, we can clearly see that we have two associations here. Okay, it intersects the graph at 2 points. For this particular y, let me call it this one y1, this is y2. So for y2, again, we have two associations. For y3, let me take 0. For 0, we have exactly one association. So because f of 0 is equal to 0 square, which is equal to 0, so that means here we have exactly one association. So far, the definition is satisfied. But if I take any point below 0, let me call it y5. Okay. So if I take a horizontal line here passing through y5, we can clearly see that there is no association because graph of x square lies above the x-axis. Okay. So which means that for y5 there is no association, and we should have exactly one association for surjection. Okay. So that means this function as a whole is not surjective. But if I restrict the codomain, okay, if I restrict this codomain, if I don't include these points, then I can make this function surjective. Okay, because if they are not part of codomain, then I don't need to check there. I don't need to check for any associations there. Okay, so if codomain is equal to this set from 0 to infinity, where 0 is included, then there is no issue. And there was no issue with the domain, so domain can be R. It can be any real number here. There is no issue with that, right? But codomain has to be restricted. Codomain cannot be the whole real line. It has to be from 0 till infinity. And we can also call it R plus, or we can also call it R more than equal to 0. Okay. Let me make it clear right now that R plus is same as 0 to infinity, and we'll be using the symbol R plus plus for strictly positive real numbers. Okay. So here 0 is not included. Here 0 is included, right? But here we have not included 0. Basically, it is R more than 0. This is R more than equal to 0. Okay, so we'll be using these symbols. So in some books, these symbols can be different. Okay, but we'll be using these symbols. Now my question to you is whether R plus is a subset of R plus plus, or whether R plus plus is a subset of R plus, or whether they are equal. Which one is out of these three, which ones are true and which one is false? That's my question to you. Is it true or false? True or false? True or false? Karo. Check karo. That's right. So clearly R plus is a bigger set because it includes 0 as well, right? Let me draw a real line. So R plus is this, and R plus plus is like this. Okay, it does not include 0, R plus plus. So clearly R plus, R plus plus, R plus, this includes 0, so it is a bigger set than R plus plus. So that means R plus will be a superset. Okay. So this one is correct. R plus plus will be a subset of R plus. And clearly they are not equal because R plus plus, R plus includes 0 and R plus plus does not include 0. Okay. Does not include 0 and everything else is same. Includes 0 and everything else is same. So which makes it a bigger set. So R plus has all the elements of R plus plus. Okay, but R plus plus does not have 0, which R plus has. So that makes R plus a bigger set. Okay. So basically R plus plus is contained in R plus. All right, moving on. Again, let's talk about the cardinality. Suppose there is a function g, domain is A, codomain is B, and we know that it is surjective. Okay. Now, what is the relationship between cardinality of A and cardinality of B? That's the question. So whether number of elements in set A should be more than or equal to number of elements in set B, or number of elements in set A should be less than or equal to number of elements in set B. What should be true? All right, check करते हैं. So we have set A and set B. Okay. So if I take, let's say, elements A1, A2, and A3 in set A and only B1 in set B, okay, I can map all of these elements in set A to B1. Is this a function? Well, yes, because each element in set A is associated to exactly one element. There is exactly one arrow coming out of each of these elements in set A. Okay, so that makes it a function. Is it a surjective function? Well, each element in set B should have at least one association. So B1 has 3 associations, so it is a surjective function. Surjective function. It is surjective. So which means that number of elements in B can be less than number of elements in set A. Okay. What about equality? A1, A2, A3, B1, B2, B3. If I map each one of them, if I map A1 to B1, A2 to B2, and A3 to B3, clearly it is a function and it is also surjective because each of them have at least one association. So yes, it is also surjective. So we can have equal number of elements in A and B as well. Okay. But what's the issue with if I take a case where number of elements in set A is less than number of elements in set B, then what will happen? Can I make that function surjective? Let's check that. A, B. Here we have, let's say, A1, A2, and A3, and here we have B1, B2, B3, and B4. Okay. So A1 is associated to B1, A2 to B2, and A3 to B3. Okay. So each element in set A is associated to exactly one element in set B. So it is a function. Function, yes. Is it surjective? No, because B4 has no association. It should have at least one association. So if I try to associate it to one of the elements in A, well, the problem is that it is now no longer a function because A3 cannot be associated to more than one element in B, right? Because the definition of function says that each element in A should be associated to exactly one. Okay, exactly one element in B. But here it is associated to two elements in B. So it is, so no longer what I do, I cannot make this surjective. So if cardinality of A is less than cardinality of B, then we cannot have a surjective function. All right, so the relationship should be that cardinality of A should be more than or equal to cardinality of B. Only then we can have a surjective function. Okay, so this should be the valid relationship between cardinality of A and cardinality of B. All right. Now let's solve some questions from past years. So this question is from ISI 2007. Yeah. So consider the functions f1 equal to x square and f2 equal to 4x square plus 4x cube plus 7, and they are defined on the real line. Okay, so the domain is real numbers. Then options are f1 is 1 to 1 and on to but not f2. f2 is 1 to 1 and on to but not f1. Both f1 and f2 are 1 to 1 and on to. And option D is none of the above. So we have to check both the functions whether they are 1 1 or on to or not. Okay, and then we can choose the right option. All right. So before looking at this, before looking at the solution, you can just pause the video. If you are looking at it on the YouTube, then pause it, try it on your own, and then you can confirm your answer by looking at the solution. All right. Okay, let's begin with f1. Let's check whether f1, which is equal to x square, is it 1 1 and on 2 or not. Okay, let's begin with 1 1. Is it 1 1? Let's check that. So we know that the graph of x square looks like this. So there is a y such that we have two associations. So horizontal test says that, horizontal line test says that it is not 1 1. What about on 2? Is it on 2? Well, for each y, it should have at least one association. Okay, so here we have two associations. Here we have exactly one association, but here we don't have any association. Okay, and for it being surjective or onto, it should have at least one association. So here, for any y less than 0, there is no element in x. There is no associated element in x. So this implies not onto, right? So it is neither 1 1 nor onto. What about 4x cube plus 7? Is it 1 1 and onto? Let's check that. So second function is 4x cube plus 7. Okay. Well, we know that x cube looks like this. X cube looks like this. If I multiply 4 to it, it will get closer to y-axis, right? Because let's say earlier it was reaching at 1, but now it will reach at 4 at 1, right? So it will get closer to y-axis. And now when I add 7 to this, this function will shift up, right? If I add 7, this function, and why it will shift up? Because y is equal to 4x cube plus 7. So if I am adding 7 to 4x cube, I am actually adding 7 to y, okay, and y increases in upward direction. So this graph will shift up. So it will look like this. Okay. So now the intercept will be at 7. So this is the graph for y equal to 4x cube plus 7. Let's confirm this. So if I take 4x cube plus 7. Okay. Now see this. So the new intercept is at 7. Okay. And it looks like same as x cube, and it is just shifted up by 7 units. All right. So clearly it is clearly a strictly increasing function. If I find out the derivative of this function, it is equal to 12x square, which is strictly positive for all x except 0. And if I add 0, it is equal to 0. So it is a strictly increasing function with derivative being 0 at 0. Okay. So it is a strictly increasing function, which directly means that it is a 1-1 function. So 1-1, yes. What about on 2? Again, we can look at the graph. We can see that it is moving downwards towards minus infinity, and it is moving upwards towards infinity. Okay. So for all y, we can see that there is one association, right? At all points, there is one association. For this y, there is one association. For this y, there is one association. For this y, there is one association. Okay, we discussed about this. So it is a strictly increasing function, which makes this function onto as well. And strictly increasing, and it is moving in both directions. Okay, so if I check at any point, if I check for any element of the codomain, we can clearly see that there is at least one association. Okay, so which means it is onto as well. So which means that f1 is neither 1-1 nor onto, but f2 is both 1-1 and onto. Okay, ऑप्शन देखते हैं. So f2 is 1-1 and onto, but not f1. So answer is option B. f2 is both 1-1 and onto, but not f1. So let's continue in the next class. If you have any doubts, you can ask them in the beginning of the class. Okay. See you in the next class then. Bye.